So far, we have built APIs to manage customers, genres, and movies. Now let's take this application to the next level. So I want you to implement an API to manage the rentals. We should be able to create a new rental. So we should post to an endpoint like this. And we want to get the list of rentals. So get/API/rentals. So go ahead, do this exercise, and then come back, continue watching. All right, let's take a look at my solution. So in the models folder, we have a new module, rental. Let's take a look at this schema. So here we have a customer property, but note that I have set the type of this to a custom schema that I have defined here. In other words, I'm not reusing the customer schema that we defined in the customer module. The reason for this is because our customer can have 50 properties. We don't want to have all those properties inside this object. We only need those primary properties that we need when displaying the list of rentals. So those absolute essential properties. So we have name is gold, which can potentially be used to calculate the rental fee. Perhaps we want to give a discount to our gold customers. We also have the phone for each customer, because when we look at the list of rentals or a single rental, we need to have the contact information for this customer. Perhaps we want to call them. Now, chances are your solution might be different. Now, you might ask, what if in the future we need to display more information about this customer on the rental page? Well, here we'll have the ID of the customer as well. So for anything additional, we can always send a GET request to our customer's API to get a complete representation of that customer. So the properties I have included here are the absolute essentials that I'm pretty sure we need when displaying the list of rentals or a single rental. Now, by the same token, we have this movie property here. And again, I have set the type of this property to a custom schema. I have not reused the movie schema that we defined in movie.js. Because as I said before, our movies can have 50 properties. We don't want to add them all here. So for a rental object or rental document, we only need the title of the movie and daily rental rate. Because in the future, we're going to use this to calculate the rental fee. So if we include this in an embedded document, we don't need an additional query to the movies collection to calculate the rental fee. Okay? Now note that both the customer and the movie are marked as required. So here's the movie property. In this schema type object, I've set the type to this custom schema. I've also set the required property to true. We have another property that I called date out. It's a date, it's required, and the default value for this property is the current date time. We also need another property that is date returned. This is also a date, but it's not required because initially we don't have a value for this property. And then in the future, when the customer returns a movie, we're going to set this value. And the last property we need here is rental fee, which is a number, and it cannot be less than 0. So this is the shape of our rental documents in MongoDB. Chances are your implementation is different. As long as you have followed the same principles, it doesn't really matter. So don't worry if your solution is not exactly like mine. All right. Below that, we have our validate rental function. Note that the schema that we have here is very different from the schema we defined for our rental documents in MongoDB. So here we have only two properties, customer ID and movie ID. These are the properties that the client sends to the server because we don't want the client to set the date out property. This should be set on the server based on the current date time. By the same token, I don't want the client to set date returned or rental fee. These should be set on the server. So when creating a new rental, the client should send only two values, customer ID and movie ID. Now let's take a look at my API implementation. So here we have rentals.js. We have an endpoint to get the list of rentals. Very simple, just like before. except that here I'm sorting by date out in a descending order. That's why we have this minus here. Now let's take a look at our other route for creating a new rental. So first we validate the request. If it's not valid, we're going to send a 400 error. After that, we want to make sure that the customer ID that the client is sending us is a valid customer. That's why here we find the customer by its ID. If we don't have this customer, we respond with a 400 error and say this is an invalid customer. By the same token, we need to validate the movie ID that the client sends us. So we find the movie, and if it doesn't exist, we return a 400 error. Also, we want to make sure that this movie we are renting out is in the stock. So if number in stock is 0, we want to return a 400 error with a message like movie not in stock. Okay? Now after this point, everything is valid. So we create a new rental object. We set the customer property to a complex object with these 3 properties: ID, name, and phone. We store the ID here because in the future, perhaps we need more information about that customer that is not available in this rental document, so we can query that customer later. Similarly, we have this movie property, which is a complex object with 3 properties: ID, title, and daily rental rate. So note that here I have not set the date out property, because earlier we defined this property to have a default value of the current date time. So when we save this rental here, Mongoose will automatically set that property. Now after that, we need to update number in stock property of the movie. So we need to decrement the stock and then save this as well. Now here we have a problem. We have 2 separate operations. It is possible that after we save this rental, something goes wrong. Maybe our server crashes or connection to MongoDB drops. So perhaps this second operation will not complete. That's where we need a transaction. So with a transaction, we can ensure that both these operations will update the state of our data in the database, or none of them will be applied. So they are atomic. They both complete or they both roll back. Now, in a lot of relational databases, we have this concept of transactions, but in MongoDB, we don't really have transactions. There is a technique that is called two-phase commit, which is beyond the scope of this course. That's an advanced topic related to Mongo. But in the next lecture, I'm going to show you an NPM package that simulates a transaction in Mongoose.